Okay, we're going to make an attempt in 2 minutes or less to answer problem 45, which is inside Rn, I have two subspaces that are too fat, right? Together, when I add them together, they make more than the whole space. I'm supposed to show that there's some non-zero vector that's in both v and w, right? So the way I'm going to do that is I'm going to say, all right, so if they add up to too much stuff, right? What that means is that there's a basis for v and a basis for w. So I'm going to say, all right, so let's suppose that a basis for v is k things, right? So that's going to mean that v is the span of a set of vectors v1 through vk. Then w is the span of a set of vectors w1 through w, and this is where things get a little wild. I guess I'm going to say m, right? And what I know is that m is bigger than n minus k. You guys with me on that? Okay, now in order to solve this problem real fast, what you want to do is you want to look at those two sets of vectors together and notice that they can't be linearly independent. What that's going to mean is you're going to get something like you get a1 v1 up to ak vk plus b1 w1 up to bm oops, that's ww, that's stupid, is the zero vector, right? That's since Rn is n dimensional and there are too many vectors in this combined set, right? So if I stick these two sets together, they span Rn. They have to. Well, they don't have to, but they have to have at least that many vectors, right? So worst, like best case, they cover Rn. They have to be linearly dependent because this is strictly greater, right? So these things, there's too many of them. They can't form a basis for Rn. They have to be linearly dependent. They don't have to span the whole thing, but there have to be too many at least. That means that I can say that these vectors add to zero with not all of the a's and b's being zero. If you subtract all the vectors w to the other side, then you have a vector on the left that's in v that's equal to a vector on the right that's in w. That should be it. You can argue that neither vector can be the zero vector because the two sets are themselves linearly independent, but that takes a second. I think I've used up 4 minutes. Good enough?
Yeah, that was surprisingly easy. The second you said greater than n, for some reason that just made it click, and I was like, oh right, they have to like overlap at some point.
Yeah, basically it's really that's what's going on, right? Is there's not enough space to put W in there without overlapping V. And so you just use the basis to say, okay, what does it mean to overlap? Well, it freaking means that a linear combination here and a linear combination there is going to equal the zero vector, subtract, and whoopsie daisy.
That's cool.
Yeah, these are super cool questions. Some of these are the most frustrating math questions because the if you know the answer, you can write it down in a couple of minutes. If you don't know the answer, you can stare at it for hours, and that's totally fine. Like that happens. That is how you learn math. Actually, is by staring at it for hours. You do not learn math by having me tell you the answer in 30 seconds. Um, in the same way, right? That you don't get fit from watching YouTube videos about fitness, right? You get fit from doing fucking stuff. So I've like math is at least a little bit about that churn and that struggle, and then we try to like help you out if you need it. But if you haven't worked for it, you won't tend to remember it. You'll just remember there is an answer and who told you sometimes, which is really frustrating because then you have to write them an email and be like, "Hey, wait, what?" All right. Any questions on this? Okay, I realized that was quick. You guys got it.